Hi all, this is lecture 19 on 8.3, the center of mass. I'm not really going to go through a lot of details on this, but typically when we have a plate, right, meaning thinking 2 dimensions as opposed to 3, you want to find the center of mass, right? And if that plate has a uniform density, meaning that it's the same everywhere, then that center of mass is also called the centroid. And the coordinates of the center of mass can be found using these two formulas. So when we're finding a center of mass, we're doing really 3 calculations. You've got to find the area first, circa back in chapter 6 when we found the area under a curve. And then you want to find these 2 integrals. So the integral from a to b of x f of x is your x bar, and your y bar, which just represents the y component of your center of mass, is the 1/2 f of x squared. So let's run through a couple of quick examples here. So to find the center of mass of the region in the first quadrant bounded by cosine from y equals 0 and x equals 0. So if we start by sketching the region, cosine starts at 1, and it hits 0 down here at, let's see, it hits 0, cosine, so this would be at pi over 2, right? Cosine is 0 at pi over 2. So we're talking about this area. We want to find the center of mass of the plate that looks like this. So the first thing we want to do is look at its area. So we find the area by finding the integral from 0 to pi over 2, because we're using x's, of cosine x dx. So this is going to be sine x from pi over 2 to 0. And that is the sine of pi over 2 minus the sine of 0. Sine of 0 is 0. And the sine over pi over 2 is 1. So my area here is 1. Then, once I've done that, let me move this to the side a little bit. Oops, I took my line with me. So that's my first calculation. Then I want to calculate x bar. So x bar is 1 over the area, which is 1, the integral from 0 to pi over 2. And this time I want x times f of x. So x cosine of x dx. Okay, now I did not give you a lot of room for this, and I probably should have, because these integrals aren't necessarily quick and easy. And this one in particular is going to require by parts. So your u is your x, and your du is dx. Your dv is cosine of x, and your v, the antiderivative here, is sine x. So when we go to find my x bar, this is u times v, which is x sine x, evaluated from 0 to pi over 2, minus the integral of sine x from 0 to pi over 2. dx. And that gives me x sine x from 0 to pi over 2. Antiderivative of negative sine x is positive cosine x from 0 to pi over 2. All right, so this gives me pi over 2 times the sine of pi over 2, which is 1, minus 0, plus the cosine at pi over 2 is 0, minus the cosine of 0 is 1. So we end up with pi over 2 minus 1 as our x bar. Then to find y bar, let me go over here to the side. We want, your formula for y bar is 1 over the area, integral from a to b of 1/2 f of x squared. So our area is 1, so we just have the integral from 0 to pi over 2 of 1/2 f of x, which is cosine, squared. And in this case, we're going to have the 1/2. We know that with even powers, we're going to use our double angle formulas. So this is 1 plus cosine of 2x all over 2 dx. So this is 1/4 integral from 0 to pi over 2 of 1 plus cosine 2x dx. And this gives us 1/4 times, antiderivative here is x plus 1/2 sine 2x from 0 to pi over 2. So that's 1/4 times, when we plug in pi over 2, we get pi over 2, plus 1/2 sine of pi. Sine of pi is 0. Minus, when you plug in 0 for x, you get 0, minus 1/2 the sine of 0, which is also 0. And that's going to give me, let's see, pi over 8. So my center of mass happens to be pi over 2 minus 1, comma, pi over 8. Okay, and that's the way we do it. Example 2, we're finding the centroid, so we're assuming here that the density is uniform, and we get this guy. So we have y equals x and y equals x squared. So we're working with this region here. All right, and so the first thing we do is find our area. So the area is the integral. And by the way, if you set these two equal, this is just 1. If you set them to equal and factor, you get x times x minus 1. And so that gives you 0 and 1. So you want the integral from 0 to 1 of the top, which is the x, minus the x squared, which is the bottom. So this is 1/2 x squared minus 1/3 x cubed from 0 to 1. And then you get 1/2 minus 1/3 and 0. So 1/3, this is going to be 1/6. So my area here is 1/6. Now, the challenge with this one, when we go to set this up, your f of x here, what does your f of x look like? And you want to kind of think about this the same way we think about our discs and washers. So we are working with, this time, two functions, one above and one below, that's creating our region. And so when we go to set this up, it's going to look slightly different than last time. Okay. So with discs and washers, when you think about this, our x bar, so for a region bounded by two functions, f of x, where f of x is greater than or equal to g of x. Okay. So in this case, we're thinking about our x being greater than or equal to x squared, right? Okay. So what do they look like? Well, x bar, the adjustment that we make here is 1 over a, integral from a to b. And I'm just going to take x times, and I'm going to subtract the two functions. So top minus bottom, f of x minus g of x, just like we did with area. Okay. Essentially what you're thinking about is if I found the center of mass for function f of x, and I found the center of mass for g of x, and I subtracted those two, that would give you the center of mass for the area between the two curves. So we just subtract the two. For y bar, it's going to be similar, except it's going to be outside the square. So we get 1/2 times f of x squared minus g of x squared. So you're squaring each function before you subtract. Okay. So that's what we're going to be using here. So in order to create our x bar, we want 1 over the area. The area is 1/6, so 1 over 1/6 is 6 times the integral from 0 to 1 of x times my functions subtracted from one another. The top function is x, the bottom function is x squared dx. So we got 6 integral from 0 to 1 of x squared minus x cubed. And this becomes 6 times 1/3 x cubed minus 1/4 x to the 4th from 0 to 1. So that's 6 times 1/3 minus 1/4. And 6 times, let's see, 4 minus 3 is 1 up top over 12, gives me 1/2 as my x bar. So my x bar is 1/2. Then for y bar, we're 1 over the area, so that's 1 over 1/6, which is 6, integral from 0 to 1. And this time I want a 1/2, which I can actually bring out front. But I want f of x squared. F of x is just x, so I want that squared, minus g of x, which is the x squared, squared. So that gives me 3 integral from 0 to 1 of x squared minus x to the 4th dx. And this is 1/3 x cubed minus 1/5 x to the 5th from 0 to 1. And that's going to give me 3 times 1/3 minus 1/5. And let's see, this is 3 times 2 over 15, or 6 over 15. And that's my x bar, so that's what goes over here. So when we've got two functions, we just think about subtracting the two of them.